good afternoon. It's so wonderful to welcome you all back to Bite-Sized Corrosion, to our winter series on corrosion perspectives. Very often, I think that our corrosion experience where we are is very different from the corrosion experience in another place. And I'm hoping that in this series, we get to see that whilst corrosion is different, it also isn't. And we're so privileged during this series to have really distinguished international corrosion experts who'll be sharing their perspectives with us. Dr. Marcus Buchler from the Swiss Society of Corrosion Protection and Mr. Ken Lax, who's the Director of Corroconsult in the UK, will be joining us in the coming weeks. As you well know, those of you who've been with us before during the past few series of Bite-Sized Corrosion, we've been talking about the importance of taking the microclimate or the immediate environment into consideration when we select the material or even the coating for any particular project. And that is absolutely correct. But we also sometimes fall into the trap of thinking that our experiences of corrosion are completely unique. And I'm hoping that we'll explore that concept a little bit more. Now, kicking off our series today, I'm delighted to welcome Neil Webb back into the mic. Neil is very well known to all of us. In fact, here in South Africa, many would call him Mr. Corrosion South Africa. So Neil, thank you for always being so willing to share your wealth of experience and your expertise with us.
Hi, Vanessa. Your comments about corrosion being always the same in spite of differences is well illustrated by an experience that I've just had. A couple of weeks ago, I spent a very, very enjoyable week in Slovakia, of all places, where the European Society for the Corrosion Control on Pipelines in particular meets. And this organization known as COCOR meets every year. And we had our first live conference again this year after a 3-year break with a COVID situation. And at that conference, we had a plenary lecture given by Professor Alison Davenport from the UK, who was concentrating on localized corrosion. But the thrust of her presentation was that a metal ion, which is the product of corrosion, it's the part of the metal that forms rust when it corrodes, it doesn't know whether it's in a pit or in a crevice or on a ship or in South Africa or in Switzerland or in UK or America or Australia. It really just doesn't know. It only knows what the immediate environment in the microclimate is right next to the surface of the steel is. And so from that point of view, corrosion mechanisms are all very, very similar. Mm-hmm. And it is the environment and the morphology around that particular situation that actually gives rise to the different types of corrosion that occur, the nomenclature that's used. For example, one of the famous writers of corrosion textbooks was Mars G. Fontana, and he referred to the 8 forms of corrosion. But at the micro scale, they all involve this little metal atom that's in the iron becoming an iron-ion in solution. So from that point of view, it's the same no matter where you are.
That's so interesting, and it must have been absolutely wonderful to meet other corrosion-minded people, as it were. Stuck here in South Africa, we tend to feel quite isolated, and it's hard to envisage a whole conference dedicated to corrosion.
Yeah, it's a really inspiring event to go to because the discussions are cutting edge. And we talk about things like using pH to determine whether or not something's under cathodic protection instead of measuring potential. But it's difficult to measure pH, so we use potential as what we call a surrogate criterion. And that's the sort of discussions that are taking place. Really, really cutting edge stuff. And a lot of the work that is done in that conference goes on to become ISO standards, for example. So it's inspiring to be in that situation.
Neil, with your experience of that, if we come back to the South African situation, do you feel that we are backward here at the tip of Africa?
Not at all. In fact, many years back when I first started in the business, I had the opportunity to go to a conference in Frankfurt. This was the International Corrosion Conference. And I was really excited because I'd only been in the industry for a couple of years. And I thought, wow, here's the opportunity to go and ask some of the questions that have been bothering me. So we come into the first relevant session. It was probably about cathodic protection. I don't remember what it specifically was, but I remember the experience. Get to the end of the presentation and yours faithfully sticks up his hand and says, yeah, but what about this? And there's this sort of quietness over the room. And eventually the speaker says, well, when you find out, please let us know. and that was an eye-opener, because it made me realize that we are not lacking or lagging the international situation. And my experience at this conference now, again, just reinforced that situation. We tend to take a different perspective in many ways. We don't have direct online X-ray spectroscopy or photo analysis of some description or another, where you use high energy focused beams to look at a surface as it corrodes under an electron microscope. And we tend to leave that highly theoretical research to, as our good colleague Bruce Trembling says, we leave that to the guys with thick glasses and white coats. Now, my glasses are not very thick, so I don't fall into that category. The reason I went to the conference was to present a paper on the practical experience of corrosion of zinc electrodes in association with cathodic protection and ACM mitigation. And there were a couple of other papers on similar topics, because AC corrosion is a very pertinent subject at the moment, in pipeline corrosion in particular. And the other topics were extremely theoretical, all done in a little beaker in the lab. And we had taken some industry standard materials, buried them in the wetland at the office, took a commercial power supply, linked it up, measured the results, and the most accurate piece of equipment we used was a highly sensitive mass balance to measure the weight loss. And so at the end of the day, we had some weight loss measurements under real conditions. And they gave us some surprising results, which surprised us. It surprised some of the people overseas as well. And I had one of the comments come back from the audience saying, it's good to see results from real tests. And I think that's where we tend to have a different perspective, perhaps, is that we tend to take the theoretical principles, apply them, and see what happens.
Well, it's very encouraging to hear that we have no reason to be ashamed of our work, as I always say, at the tip of Africa. And yes, I think we tend to be looking all the time for very, very practical solutions. And let's face it, we have some very practical challenges here. I think we also have some differences that we do experience when we apply corrosion protection. So I guess if we're forewarned about it, we can be a little bit forearmed. Can we talk about some of the areas where we approach the application of corrosion protection a little bit differently, say here in South Africa, in Southern Africa, than perhaps in the Northern Hemisphere?
Yeah, well, there are two particular parameters, I think, that come to mind. One of them is temperature. And corrosion is an electrochemical process, and it's a basic principle of electrochemistry that a chemical reaction, or the rate of a chemical reaction, doubles for every 10 degrees C increase in temperature because of the mobility of the chemical species that are reacting. So if you have something that is sitting at, say, 20 degrees and you increase the temperature to 30 degrees, it's not going to boil. It's not going to necessarily change its physical state, like going from ice to water or anything like that, but you get a marked increase in the rate of the chemical reactions that occur. So things oxidize faster, the conversion of salts in the corrosion process occurs faster, the diffusion of oxygen occurs faster, the diffusion of moisture occurs faster. And so where that is of particular interest is perhaps in the coatings industry, where you have coatings that are formulated to react in order to cure. So you take a liquid coating, apply it, and it'll initially dry, and then it will cure chemically. And the drying process is just evaporation. But if you increase the temperature, you increase the evaporation rate. If you take your conventional two-pack epoxy glue that we're all familiar with, and you mix the two components together and they react and they cure. And the same happens with a coating. So there's often a coating system which comprises of two components. Mix the two together, they react and they cure. Now, if you have an increase in temperature, that curing process is going to take place a lot faster. And so we have the situation that if you were to take a product that was formulated for Europe, for example, and apply it in South Africa, it would have a far shorter pot life. In fact, it may not even be usable just because of the ambient temperature. So that's a real challenge. And we've had numerous products that have been brought in by well-meaning importers to say, oh, we've got this fantastic new material and it's been proven overseas and here's all the results and what. And we apply it locally and it's either impossible to apply or it doesn't work.
And there's that tendency that many of us have is if it comes from overseas, it's better, or it's what we should use. And I think this is a timely reminder that very often we need to, again, as we've said in other series, do the necessary trials, field tests here under local conditions, because as you rightly say, it is hotter and reactions will occur faster. And so it can be problematic to assume that we can apply a particular solution in a copy-paste or mirroring experience rather than actually thinking it through.
Another aspect of that is that there is always the pressure from government for local content. So a material that works overseas, bring it out here, and you're now under pressure to substitute local materials for it. And so maybe this product has got 5% butyl alcohol or polyisobutylene or whatever, it doesn't matter, sourced overseas. You source the same material from South Africa, and there might be just a slight difference in the purity of the material or in the absolute formulation, which can play absolute havoc with the characteristics of the material that you're going to use locally.
I agree. We do need to be very careful. But I'm also aware that not everything we use is kind of negative. Sometimes we've had successes here in South Africa where overseas they've kind of, spare me, I can't bear to think of using that product. Have you got any examples in that line?
Well, I think one of the best illustrations of that is the use of tape wrapping for pipelines. There were a number of pipelines in the 70s and the 80s, some of which I was involved in, where the pipes were tape wrapped instead of having a factory applied coating such as a trilamate material or a bitumen material or whatever. So they were wrapped with plastic tape, glorified insulation tape, very glorified. The tape is a multiple component laminated system. It's relatively hard compared to electrical insulation tape anyway. You have to apply it under controlled tension conditions. And we've got some pipelines that were laid in that time which have been exposed now for 30 plus years under really arduous conditions in terms of very high negative potentials, for example. And they have performed extremely well. And the reason for it was the extreme care that was taken, A, in the application quality control, and B, in the installation quality control. So, for example, the pipelines were laid in sand padding, not just thrown in the ground and had rocks thrown over the top of them. And yet, in many, many places in the world, tape wrapping is regarded as an anathema. Don't use tape, it doesn't work. As I say, we've got tape-wrapped pipelines which are decades old. And in fact, it was very interesting. A couple of years back, we had occasion to work on some of those pipelines, those original pipelines from the 1960s. And the entry to Durban Harbour was being revamped to allow trucks to have easier access. And we had to take some of these pipelines and put them into culverts. We didn't move the pipes. We built culverts around them. And they were excavated and then recoated and placed inside these culverts. And those wrapping systems were in perfect condition. Like I say, 40 odd years later? It really comes down to the quality control of the system and the realization that you cannot just choose a particular corrosion protection system and then forget about everything else. You've got to match the corrosion protection system to the environment. And where possible, like in a pipeline, you've got to match the environment to the corrosion protection system.
So true, Neil. It's quite an interesting concept. I was involved with the AfriCorps Congresses over several years, and their tagline was African Solutions to African Corrosion Challenges, which was very apt because I think we do need to encourage African researchers and scientists to find solutions. But in many ways, we're also seeking African solutions to worldwide corrosion problems because iron doesn't see whether it's in Africa or Europe, as you've said. But again, as you've indicated, we may need some specific adaptations. And I think also sometimes not only in using it like the tape wrapping with the padding that works best for it, but I'm aware of some adaptations that have been made because there are other factors that we need to consider. You and I were chatting recently about the use of AC decouplers. Would you like to elaborate on that?
Staying on our pipeline theme, the problem with AC, of course, is that to reduce the AC interference, which can cause corrosion, but is actually more of a hazard in terms of electrical shock. You want to earth the pipeline to reduce the AC, and that is totally against the principles of cathodic protection, where you want to insulate. So you have these decouplers, which will conduct AC and block DC. So cathodic protection potentials, -1, -1.5. And if you look at the standard AC decouplers from overseas, they have a ±2 volts. And on special delivery, you can order +1, -3. Now, with the levels of interference that we experience in South Africa, those decouplers would conduct continuously and drain the CP system because of the high negative voltages that we experience. And so our South African designers and equipment manufacturers are now manufacturing decouplers with a DC blocking voltage that is adjustable in some cases, or it comes in at somewhere around 9 to 12 volts in order to be able to handle these very high negative voltages that are experienced. And often with the international courses and so on that we get involved in, you find you get a lecturer coming over here and they start talking about electrical interference. And yeah, man, we've got to control 100 millivolts. And we show them some of the interference situations that we experience here in South Africa, and their eyes go up. Yeah.
I think that does also highlight some of the African innovations that we need to apply within the corrosion context. But I guess if we head back to where we started and we'd say, well, if we're looking at corrosion in Africa, is there a difference?
Well, you take the words out of my mouth, because in the very first AfriCorps conference, I gave a plenary presentation on corrosion in Africa. What's the difference? And the bottom line really was, no, there's no difference. The corrosion processes are the same, but the intensity is different. In some ways, you can say that people overseas tend to use elegant solutions where we use arrogant solutions.
Absolutely. And in fact, it just ties back to where we started with Professor Alison Davenport saying, effectively, iron is iron, and iron will behave as iron will behave wherever it finds itself.
Correct.
Well, thank you, Neil. It's been a fun discussion to have today, talking about some of the perspectives on corrosion that we experience here in South Africa.